Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam.
Good morning, sir.
Waalaikumsalam.
Adrin Shafrin ada? Adrin Shafrin. Ada tak? Tak ada. Liana Afira? Liana Afira. Tak ada. Raja Eddie Ray? Raja Eddie Ray. Ada Raja Eddie Ray. This is section 1 kan? Bila apa saya tengok. Section 1 kan? Haziq Irfan? Haziq Irfan?
Ada, sir.
Betul lah, section 1 kan? Alright. Okay, today we are going to continue with chapter 3 but before I forget just to remind you guys, this week we are going to have quiz 1 as scheduled kan. Quiz 1, so I plan to release the question on Saturday on Saturday. It's just a simple assessment class. Maybe objective types of question. So you need to log into your Kalam and the question is going to be there. So you can log into Kalam anywhere between 8 a.m. to 5 p.m. this Saturday. So once you start answering, so you cannot stop. You need to finish all the question within maybe 10 to 15 minutes only. Maybe 10 questions, something like that. Okay. I haven't set up the question yet, but around 10 questions, something like that. Okay. So cover until chapter 3. Boleh this Saturday. Anytime you free between 8 to 5 p.m. Boleh?
Boleh, sir.
Boleh, sir.
Okay, so last week we already covered until, okay, refresh sikit. So we already covered the sequential logic structure and mainly the PAC, IC and IPO kan. So I already showed you the relationship between the PAC, IC, IPO, pseudocode and algorithm, dash checking and flowchart. Hopefully you guys still remember the linkage between all these elements. And so basically we finished with the analysis part, okay? The problem analysis using these tools. And right now we are moving forward to this part, okay? The designing, okay? This is design phase. Okay, we conduct the pseudocode, okay, or algorithm or flowchart. And dash checking, if you still remember, okay, I mentioned dash checking is, the purpose is only for verification of our algorithm, and this is for verification. This is for design, okay, this is for design, this is for verification. Okay, so we start with pseudocode and algorithm. Okay, pseudocode and algorithm. Alright. Okay, in general, pseudocode and algorithm is the same way to represent a program design. It is the same, okay? But how we represent it? is slightly maybe a little bit different, okay, in terms of formality. Okay, pseudocode is informal. Okay, informal way to represent a program design. Algorithm is formal. So what is informal and formal? So we are going to look at the different later on. So what is pseudocode? We can say that pseudocode is instruction to solve a problem lah. Basically, we already construct the the basic structure of pseudocode when we do the IPO. Okay. For example, this is our IPO. Okay, the one that we discussed last week. We already changed this to the module name. So make sure you use module name over here. Read, print, calculate. Not the numbers. So where's the program structure over here? The instructions. The instruction. Which part? This part over here. Okay. So what we are going to do in pseudocode or algorithm, basically we are going to copy and paste. Okay, easy Copy and paste. Let's say you already have a correct IPO. It is a correct IPO. Then just copy and copy the processing section over here and put it in your pseudocode or algorithm. Okay, this is it. It should be the same. Maybe just a little bit different compared to the IPO processing. Okay, so this is a pseudocode or algorithm. Okay, so it is a list of instruction. What is a list of instruction? That one, 1, 2, 3, 4, 5. One is we read the input. Second, maybe we read again. Third, we calculate. So that is what we call as list of instruction. And pseudocode is informal way. Okay, while the algorithm is formal way. Alright. So three standard rules to develop pseudocode. So you need to have numbers. The numbers is very important because later on when we want to test our algorithm or pseudocode, we should use the numbers. Each instruction should be clear, completeness. Okay, let's look at the example. Okay, over here you see that we have a simple problem to calculate tax. Okay, for example, sales tax. To calculate the sales tax over here. You see over here, you see this is a very much similar with the IPO processing section. So that's why I say that it is similar lah. You just copy and paste it over here. The difference is pseudocode is informal way So what is informal way You see that it doesn't use specific variable names. Okay, it use mainly English version of representation representing the instructions. Okay, for example over here read price of item. So it explain it in details. Okay, in details using English language. How I'm going to say this? Because if we put in IPO the IPO is much more straightforward. Okay, straightforward of instruction. Okay, whereby the pseudocode is informal. So informal way by explaining the instructions in a way that everyone, whether they are in computer science or not in computer science, can fully understand the instructions. Apa kita panggil layman punya ni lah, layman punya language. Everyone can understand it is some kind of storytelling, something like that. So step by step of storytelling what these programs do. Okay, starting from read price of item, read sales of tax, And then if you see over here, this supposed to be the calculation kan. So do you see any multiplication over here? No kan? But when you read this, you see that this is a multiplication operation supposed to be multiplication, but it has been represent in a full text. Okay, so this is not what we are going to use actually in this subject. So this is just to show you the difference between pseudocode and algorithm. The one that we are going to use is standard algorithms, which is formal. Okay, so I'm going to show you the difference over here. Okay, so this is a pseudocode, and compared here is the algorithm. Okay, algorithm is algorithm, we start with algorithm, name of the algorithm. Name of the algorithm. You may put it number 1 or you may put 0. Okay. Double check. Okay, number 1 or 0, right? Mana tadi? Okay. Okay. So the difference is we start with algorithm name. Okay, algorithm name, which is for example calculate sales tax. Okay, so this is the algorithm name. Okay, and normally we put an indent. Okay, we put indent slightly to the right. Okay, for the rest of the instructions. Okay, just to differentiate it with the parent of the instruction. So this is the parents. This is the parents, and this is the end of the parents. Okay, this is parents. This is the end of the parents. We see this parenthesis. We use parenthesis a lot in algorithm and also in the real coding. Alright, so this is to show the level. The level of the instruction is the same. That's why it is in the same indent. Okay, this is the same indent. So it is in the same level. This is the parent level. So it is in the different indent. This is in a different indent. This is in a different indent, just to show the level. Alright. Okay, so okay, this is algorithm. Algo. Okay, so algorithm will use standard variable. For example, read price of item kan. Let's say you are going to use price again. So price. Tadi pula dia. Okay, price. Okay, and then this one, let's say you use apa This is you use rate to represent the sales tax rate. Or if you want to use a longer name, so you may use underscore and sales underscore tax underscore rate. Alright. Let's say we use rate to represent the sales tax rate. Okay, so this is to calculate the sales tax. So we use standard equation, which is what? What's supposed to be the equation? Anybody? Price equal to? Tax equal to? Price, then?
Price star sale tax rate.
Price, star?
Price star sale tax rate.
Star rate.
Almost. Star rate only lah. So follows the variable. So if you use rate, just rate only. So it's supposed to be price, star kan? Star representing the multiplication and rate. Okay. So this is what we call as a formal. Formal. This is informal. English version of our algorithm. And this is supposed to be what? Total or price?
Total.
Total don't use price kan, because price we already use as a input kan, so you cannot use the same lah. Or maybe you can put total price rapat kan, without space. Okay, total price for example. Okay. And then the equation?
Price plus tax.
Plus X. Okay. And print?
Price.
Okay, get it
Total price.
Total price. Finish lah. So this is algorithm. This is pseudocode. So the one we are going to use throughout the semester is algorithm. Okay, any question? It's very straightforward this one. Any confusion? The difference is compared to IPO kan. IPO, if you remember, I said over here kan. Over here you might write down calculate area only kan. Or you might write down the full equation kan. For example, this one also correct. Okay. Okay, or you may write down the full equation. So the difference is over here lah. Over here we have the keyword calculate kan. Okay, because this is where we list down all the process and the processing is based on the keyword kan. So the keyword is enter is for input kan. So we put input variable over here. The keyword calculate is for calculation kan. So we leave input empty over here, output also empty because calculation happen inside of the computer processing kan. So not being able to see by the user kan. That's why you don't have input, you don't have any output Display, you see the keyword display is for the outputs. So the difference is only this part lah. You didn't put calculate over here in our algorithm No, right? Straight away we put the equation. That's only the difference. Okay. Clear Boleh?
Boleh sir.
Alright, so this is another example. However, this one includes the decision that's why I'm going to skip this first. Okay. So once we enter the decision chapter next week, then we are going to discuss about the decision algorithm This is description of algorithm. Basically, it is the same. It is the same. Algorithm and pseudocode is the same, only the representation is slightly, okay, just a little bit different. Okay, this is important information, guys. So each problem can have many algorithms, meaning that one problem can be when you develop a solution for specific problem, okay, there can be many ways. Okay, that's why over here shows that algorithm 1, algorithm 2 until algorithm n. Okay, there can be more than one way to develop an algorithm, okay, from one specific problem. Okay, as long as the algorithm is correct. So how do we check the correctness of our algorithms? By using the dash checking, right? Okay. I'm going to skip this. You may read this one. So this is where we are going. Where we are now. Sequential. All right. Okay. So let's go to the dash checking. Okay, dash checking also very important. Okay, you need to know how to develop the dash checking. Okay, mainly to test the algorithm lah. Okay, and okay. Okay, so this is the steps to develop dash checking. Okay, first you need to choose a simple input test cases that are valid. What is this then? Okay, for example, we have this algorithm. Okay, algorithm to calculate the circle area. Luas kan? Area apa? Luas kan? Okay, so this is the algorithm. See, this is the inputs. Okay, radius. This is the equation. This is print. Very simple. So what you need to have is this one. Choose simple input test cases. So in this case, what is the input class? Okay, correct. So this is radius. Input and only one input variable. So what means by choose simple input test case is that you choose one possible value for radius. Just a simple value. Don't choose a very complex 1 million, 2 million. No kan? Simple kan? Meaning that for example 2 kan. So the input is 2. So you list down lah. Mana saya nak tulis sini kan. For example, okay, you list down. So the input, I put I The input is 2 for example kan. It depend on the question. If the question asks you to construct what we call okay, 2 sets of dash checking table kan. So you must list down 2 input lah. So the first input is for the first set of dash checking. The second input is for second set of the dash checking. Okay, if the question doesn't mention how many set you need to produce so just put one for one set of dash checking. One set meaning that one run. Okay, one run from beginning until the end of the algorithm. That's it. That one is considered as one set. 2 set, two rounds lah. Okay, first we run with the first input, which is 2, and then the second input we run, for example, using 6 value kan. Input this I is for input. Nanti ada yang confused kan. Okay, and then the second run we use 6 for the input, which is radius equal to 6 lah. And then we do the algorithm until the end. Okay, this is for 2 sets. Let's say the question doesn't mention how many sets, so we produce only one set of dash checking. Okay, so this is what I mean by this step. And then establish expected result for each test cases. Okay, this is sometimes little bit difficult if your algorithm is much more complex. Okay, why? Because you need to manually calculate or check whether the expected output. Okay, this is manually done before you are checking with your algorithm. So you need to have an expert for the system to do that. If your system is much more complicated, okay, means that over here you need to manually check. What should be the expected output if the input is 2. Okay, the input is 2, meaning that radius is 2. Okay, input radius okay, then output if radius is 2, the output is what, class? If radius is 2, output is
4 pi.
4 pi. 4 pi ni apa? Pi ni straight away we put the value lah. Berapa pi? 3.14. Okay, use 3.14 kan? Betul kan? Betul kan? Okay, so the output will gonna be
12.7.
okay. $12.56 lah. Lebih kurang Okay. So what is the output, class? This is the value of what? Which variable?
Area.
Area Okay, area equal to 12.56. Okay, this is you need to figure out the output manually. manually. Okay. So this is what means by establish expected result. So from the input test cases, okay, that are valid, you need to establish the expected result. Okay, so you need to have this. Okay, for example, this is 1 marks. This is 1 mark. So you got 2 marks. Okay. And then identify the variable name within the algorithm. Right. So not only the input and output, you need to identify all the variable within the algorithm. Okay, identify. So currently we have radius and area only, and so radius and area only. So once you identify all the variable, okay, put it inside of the dash checking. Okay, radius, area. So let's say if you have 50 variable in our algorithm, so you need to put all 50 variable inside of your dash checking. Boleh radius, area, number ke, total. So list everything inside of the dash checking. Okay, test the algorithm line by line. Okay, keeping record of the contents for each variable. Okay, so over here, that's why we need to have line number because we want to test our algorithm. So let's say if our algorithms have 1, 2, 3, 4, 5 line number. Okay, this is important. Algorithm need to have numbers kan. Okay, it doesn't matter if you start with 0 or 1. Okay, as long as it is a numbers. So this number should be tally with this number, line number inside of the dash checking. If you have 10 line number of algorithm, make sure dash checking also have 10 line number, okay, presented. All right. Okay, and one more. Over here, you should have input and output. Input, output. Okay, so how to trace? Okay, input, output. So how to trace this one? Test the algorithm. How to test the algorithm line by line? Over here lah. Okay, this got two set kan. The one that I showed you over here is one set. Kan, for example, for one set, this is the table. If we have two sets, if the question asks you to produce two set, so you have set 1 apa kan? Set 2 what's the input? And then set 1 what is the output? Okay, set 2 what is the output based on this value? Okay, if 3 then the output is this one. Okay, if 2 radius 2 this is the expected output. So your dash checking should produce the same results as the expected output over here. Okay, so how to check? Line by line. Okay, so in line 1, nothing kan? Nothing because it is the algorithm name. Line 2, we have input for radius. So in the radius column over here, okay, we put 2. And in input or output section, we put radius. You see, this is to represent the input process. Okay, this is to represent the input process. Alright. Boleh? Okay, so this is in line 2. Okay, good. And then in line 3, we have the equation. Equation for area. Okay, so how do we get the area value? Okay, so in line 3, you see in the area section, we put all the value. Not the equation, the value. The value of all the variables involved in the equation. Okay, using the value that we got from the input process. So this is the value for the input, for the radius. So put 2 as the radius value lah. Okay, radius value we put as 2. Okay. And finally, in line 4, we have output. Over here, what missing is this one. Supposed to be, we can have more output kan. So how to differentiate all the output? Supposedly in this example, there should be this statement. Okay, area equal to the output. Because we can have more than one output kan. So how to differentiate? By putting this. So this means that this is an output. Okay, this means this is the input. Okay, this is input. This is output. Okay, clear class? Any questions so far?
No.
Okay.
Sir,
Yeah.
radius tu kena tulis question mark tu
Yes, question mark meaning that this is input process. Input only applicable for input.
Okay, thank you sir.
Okay. So let's say in the same line, we have more than one input. We input radius and for example pi over here. Example kan? Over here we have pi kan. So example over here we use pi need to be insert by user. Okay. Over here we already change kan. Straight away we put pi as the constant value kan. 3.14. Okay, no variable use. But over here let's say kan pi is not a constant value. Let's say pi is a variable so user need to enter the value of pi. Where to enter the value of pi? In line 2 along with radius kan. Okay, so what you need to do class if it is something like this? What we need to add in our dash checking?
Add line number.
Add line number.
Pi.
Okay. Okay, they can be as mentioned above kan, before this in line berapa, in slide berapa So one solution of can have one problem can be solved by more than one algorithm kan. So it is up to you kan whether you want to make it in a single line of input or you may put another line and you put read radius over here kan. Sorry, read pi for example kan. Can kan? So if you put it like this, you need to add one more line lah. Okay, in your table you need to add one more line. Okay, so line 3 is not going to be the calculation anymore kan. So line 3 is going to be the read pi. Okay. But let's say kan in this algorithm we combine together. Okay. Read radius and read pi in one line. So you don't have to add one more line inside of your dash checking. Okay. But what you need to add is another column over here kan. So we have pi kan. So you need to add another one over here lah, pi. Area and then one more column. Column ke row bawah ni? Ke bawah ni kan.
Column.
Column pi. So put pi over here. Sekejap. Dia tambah tak kat sini. Insert. Tak ada pula kan. Split cell. Okay. Okay, something like this, okay? Patut saya select semua Split. Okay. Ni kat dalam area So this is area. Lari dah. This is area equation. Mak lari dah. Okay, this is radius. Ni apa tadi?
Output.
This is output. Okay, so this is pi Okay, so pi supposed to be, what's the value of pi? Let's say user enter 3.14. Ni user enter User enter 3.14. User enter. So we need to add another one over here. Okay. Bawah dia lah Ni saya buat sebelah je Supposedly below it lah. But still in the same box lah over here. Let's say put comma lah. Boleh lah comma Pi. Apa? Pi?
Question mark. 3.14.
3.14. Okay. Show that this is input process. Okay, do you get it, class? Boleh tak? Okay, so this is if the algorithm is something like that. Alright? Okay, so clear So repeat the process using other test cases, okay, until the algorithm has reached its logical. No, this is for this okay, based on the question So if it requires for you to test for 2 sets of data, so you should have the second one. Okay, do the same process with the second set of data. Okay, this is the second set, and so on. Okay. Okay, check the expected result, establish, match the actual result. So this is over here. So make sure this value, okay, the result in your dash checking table is tally with the expected result that you calculate manually, okay, earlier process. Okay, if it is tally, meaning that your algorithm is correct. Okay, if not tally for example, this is area equal to 10.1. So not tally with this. So the algorithm is wrong so you need to recheck again your algorithm. Okay, so this is another simple example. So let's say we have algorithm to calculate the cube area again. So this is the algorithm, and first you need to construct the test data. So for example, you need to have 2 sets of data So this is the input for the first set. This is the input for the second set. And you need to produce the expected result manually. So you need to calculate manually the possible output based on this value of input. So calculate, you got this value and this value for the second set. So next is construct the dash checking. Okay, make sure you have the line number tally with the line number of the algorithm. And make sure you list all the possible variable within the algorithm. So right now we have only 2 variable, age and area. So list down age and area only. Okay, next, don't forget to have input and output column over here. Okay, so proceed with the testing. Okay, line 1 empty, nothing. Line 2 we have input, read age. So go to age column in line 2. Okay, line 2, read age column. Okay, put the value of the test data, which is 4. So 4 put over here. And don't forget to put this over here in input and output. Okay, this is to represent the input. Okay, next in the following line, in line 3, we have the equation. Okay, the equation for area. So put it in area, line 3. Okay, line 3. Okay, some of you, I'm not sure what's the problem is, but I see this common mistake done by your seniors So the line number doesn't match with the algorithm kan. I'm not sure what happened. Maybe they forget this is not just a random line number kan. You must follow the algorithm line number okay. Line 3 kan. Line 3 over here. Line 3 over here. Line 3 over here is got the meaning meaning that this is the instruction line in the algorithm. Okay, so put the equation along with the value. Okay, not just equation with value also this is a common mistake. Sometimes you forget, you just copy and paste the equation 100% kan. But in the dash checking, we are concerned about the value. Because we want to check the correctness of the algorithm. How to check? Based on the value Okay, based on the value. And finally, in line 4, we have the output process. Okay, the output process should be in the output section, but this is missing the so this is important because for example, if there's a print area and age over here, okay, print two value for two variable, area and age. Okay, so you must put area equal to 69. Another one is what, guys? Line 4.
Age.
Age kan? Equal to what? Equal to what? Age equal to 4 lah kan?
4.
Okay. So what happened if you didn't have this? So how do you want to put it over here? 96, 4 kan? So what's the value kan? How you want to differentiate it? So you must have this. Okay, area equal to 96, age equal to 4. If let's say you print more than one variable in the same line. You may have additional line print area and then line 5 print age. Boleh kan? So you are going to separate this this is in line 4, area in line 4, age in line 5. Let's say you differentiate the print process over here into two line 4 and 5, print area, print age. Okay, so last is to check the expected result Is it similar with the expected result that you calculate manually? So if it is similar, then it is proven that your algorithm is correct. Boleh? Boleh?
Boleh, sir.
Boleh sir.
Okay. Okay, this is another example. Okay, you see, this is the algorithm to calculate discount price. That's why algorithm name should be also important because it shows what the algorithm do. Okay, and then over here we have how many input? Two input. So in your test data so make sure you have two input first we have you should have discount percent equal to what, and then price equal to what and then this is the equation, this is the output. Okay, one output. So the expected output should be only one unless over here discount price comma discount so you have two output. For example, this one comma and then we have discount, so you have two output. So you need to have two output over here. Expected result you must have two first discount and then another one is discount price for the expected result. Okay. You understand, guys?
Yes.
Ni ada ni Okay. Display discount price ni. Discount price 180. Okay, result ni only one lah. Ni tak ada ni. Okay, because result is the last outputs. Okay, unless over here display discount price, comma discount, then we have the macam tadi lah, discount price. Okay, ni ada ni, test data ni expected lah, expected result. Expected. Expected result. So, okay, so based on this this value, so we construct our siapa nak tengok ni okay, we construct our dash checking. Okay, so list down all the variable 1, 2, 3. So we have 3 and 1 variable, 2, and then discount 3, discount price 4. Ni missing ni. Missing. Oh, betul lah semua ada. Okay, 4 betul lah We have 4 kan. 1 variable, 2 variable, 3 variable, 4 variable. Okay, list everything. 1, 2, 3, 4. Betul 4 variable. Okay, and then trace line by line. Okay, line 1 empty. Line 2 we have input. Input for 2 variable. Okay, discount percent and price. Okay, so using the value over here, okay, we have price 200, discount percent 10. Okay, so discount percent 10. Okay, price 200. Okay, price 200. Okay, then make it like this lah. Okay, price 200, discount percent 10. Okay, to represent inputs. And then in line 2, okay, line 3. Okay, line 3 we have the calculation for the discount. Okay, line 3 we have the calculation for the discount. Okay, you get the value. I think I prefer this one. Okay, this is straight away you get the value lah. So let's change. Let's change this one. So instead of calculating the area like this, so straight away we calculate to get the value lah. Equal to 69. This is more precise. Okay, this side. Okay, do like this class. Straight away to get the value. Okay, this is also the same. So not the equation, but we want to get the value So we want to get the value. So this one equal to 12.568. This is also the same. Equal to 28 tadi Alright. Boleh kelas? Okay, use this You want to get the value So this is much more convenient, okay, for you to check the correctness. You just put the discount equal to apa kan? So you cannot see the value. So this is correct lah, like this. Okay, so this is a third line. Okay, the fourth line to calculate the discount price. Okay, discount price. Okay, and line 5 to display the discount price. Okay, this is for the output. Okay, so line 5 we have the output. So this is the how you put output in your desk checking. Okay, so this kind of question is going to be asked in the midterm test. Okay, midterm test, you have to produce the algorithm, and then you need to check the correctness of your algorithms using desk checking. So this is not going to be given. So everything you need to figure out by yourself lah, this table. You need to construct this table from scratch. So you need to know how to construct the table. Okay, any question?
Sir,
Yeah.
I want to ask about the pseudocode.
Sudoku, okay?
During my foundation, lecturer saya ajar apa tu, so dia refer pseudocode punya.
Okay, Sudoku.
Pseudocode. Example, contoh dia.
Ni, example. Ni, Sudoku.
Tu.
Ni.
Kan yang sales tax kan, price of item times kan dulu masa saya foundation saya ni bawah yang calculation
Calculation. Okay.
sales tax tu dia memang kena guna times tak guna apa tu, tak boleh guna matematik symbol.
Okay. Pseudocode and algorithm ni, dia based on dia banyak mazhab lah.
Banyak mazhab
Yeah. Okay, sometimes when you Google pseudocode, the pseudocode mention is actually algorithms. Okay, sometimes lah, but this is based on this
mazhab.
Mazhab. Okay, it doesn't matter. Okay, as long as you understand how to represent the algorithm. Maybe masa you foundation, the one pseudocode mention is actually the algorithm kan. Algorithm kan. You use star
Atau simbol
kan. So that mazhab lain lah. Okay, but overall it is the same. Doesn't matter what the name is, as long as you can represent your design correctly. Okay, using this, which is what the formal way to represent the program design lah.
Okay.
As long as you can produce this, doesn't matter the name is pseudocode ke algorithm, it's okay. Okay.
So I can just use the symbol lah.
Yes, symbol over here. That's why I say that in these subjects, we are going to use this kind of presentation. Okay, doesn't matter the name is pseudocode ke algorithm, this is what we are going to use. Not this not this this one. This is. Okay?
Okay. Okay, sir.
Okay, any other question? Ada? Tak ada Okay, if no, then we are moving forward to the basic of flowchart. Flowchart ni very simple. Very simple. If algorithm, we representing the design of our program by using text. Okay, in flowchart, we represent our design of program by using symbols. Symbols lah. So it is up to you kan. That's why at the beginning I say that normally when you are designing your program, okay, you choose, and either you want to use pseudocode or you want to use algorithm or you want to use flowchart kan. Which one that more convenient for you kan? Normally we choose only one. Okay, either one. Okay. So let's say you are a person that love to visualize kan. You are less of reading person kan. You are more visualize person. So you use flowchart lah. Flowchart. Ya. Okay, maybe some of you which not in the computer science background kan, also have used this kan. Maybe in the mind mapping ada tak? Mind mapping kan, mind mapping something like that kan. But in computer science we have a standard, okay, standard flowchart, meaning that each symbol that we use have its own meaning. So you cannot simply use any symbol, okay, for your flowchart. So each of the symbol have its own meaning. Okay. Okay. So these are the list of basic symbols. Okay, basic symbols that is formally used in the flowchart. First, flow lines. Okay. So this is the flow lines. As you can see over here, the lines that we use is consists of only one arrow. Okay, one arrow not two head arrow one head arrow. Not this arrow over here and then we have another arrow over here, two head arrow, no one arrow because this is representing the flow. Okay, the flow, the direction of the instructions, the direction of the instruction. If you have two, then it will be hard for the reader to read the flow which way to go kan, right or left for example kan. That's why we use only standard one direction arrow. Okay, either it is go up or it's go down, go right or go left. Okay, and then we have ellipses. Ellipses. Sometimes you see like this. Sometimes you see ellipses. Ellipses. This is ellipses kan. It's not apa complete circle kan, dia macam ni kan. So this is also considered as correct lah, ellipses. So this is to indicate the start and end or stop, exit. If you have more than one module, okay, if you have function, we use stop or exit. If you have one non-module program, we have start and end only. Okay. So this is the beginning of the program. Okay, so we put start, and then the end of the program. So we use end. Okay, let's say we have this, and then we use line. Okay, straight line. This is empty program, start, end. Okay, and then we have rectangle, shows a processing such as calculation. Okay, rectangle. So rectangle, ni rectangle. Let's say we have in between, we have calculation, total kan, equal to 1 plus 2. Example, example. Any question involved in your design, you put it in the rectangle symbol. Okay. or we have initialization. Okay, for example, pi and equal to 3.142. Okay, this is not input. This is initialization. Initialization where we put initial value to a specific variable. Pi equal to, okay. So how do we representing this process? By putting it inside of rectangle. Okay, it can be equation, it can be initialization. Okay, and then we have input and output process. We represent it by using parallelogram. Okay, both for input and output. Okay, for example, we have input. So parallelogram. Okay, this is parallelogram. Input. For example, the input is area kan tadi kan? Area. So how we differentiate between input and output, because it use the same symbol kan? Okay, by using the keyword. If it is input, use keyword enter. Kan? If it is output, let's say output the same kan? Output, if we want to print area kan, you didn't use enter kan? So this is input. So use print or display. Okay, the output keyword kan. Okay. Decision is, okay, this is nanti next week when we discuss about the decision logic structure, we will use this symbol decision, diamond symbol. Mana diamond? Diamond. Okay, diamond symbol. This So inside of it, we put the condition. For example, this example don't worry about this. Next week we are going to discuss more. If apa area example okay, and then what happened? Okay, and then we have this one. Okay, this is representing a function or a module. Module. Okay, as we discussed in the IPO let's say if you have more than one module. Okay, in the IPO example, IPO. Okay, we have module read, calculate, print, calculate distance control, for example. So these are 4 modules. So we use this symbol to represent the module. Nampak flowchart ni kan. So we use this symbol to represent module. For example, module read. Module read lah. So we have how many modules in our flowchart? We have 4. So read, calculate, and so on. Okay, so this is module. And then let's say apa lagi? So we have looping. Okay, looping can be automatic or apa yang kita panggil non-automatic So automatic ni, if you are familiar with for loop kan, for loop is automatic. We call it as a automatic loop. So this is the symbol that we use, and inside of it, a specific variable used to control the loop. Okay, this is later on. Okay, discuss during the loop logic structure. Okay, not yet. And then this is also important. So let's say if your program is very long, okay, so the design is very long, and you need to have maybe 2-3 pages just to represent one program. So how you want to connect between one page with another? So we use on page or off page. Okay, for on page, if you want connection in the same page, for example this one in the same page, but you want instead of, actually you can straight away use this arrow, arrow go backs up over here without to use this. You understand me, class? For example, if you want to use arrow, so you just use arrow over there. That is allowed. Sometimes you don't want to use arrow, for whatever reason you don't want to use arrow, but you want to show the connection between this part and this part in the same page. This is the same page, same page. 1A4, for example, 1A4, the same page. You want to continue over here, so you may use this one. Okay, you see A, and then continue again with A. So this is how you do it. So this is what we call as on-page connector. Okay, it is connecting the flowchart in the same page. Okay, one page. Let's say if you have a longer version of flowchart, but you want to continue your flowchart in the next page, so we use this connector. Okay, connector. Okay, but this is actually wrong. Okay, this is supposed to be the same with this one. Otherwise, you are going to get confused. For example, this is A1, then this should be A1. Okay, it should be the same name. Okay, this is for connection to another page. Okay, flowchart. Okay, this is just a basic basic symbol explanation. So how do we want to use it? Okay, how we want to use to representing our design. Okay, so let's say if we have again, so this value over here is derived from the IPO. Okay, same way how you construct your algorithm, so this is over here we obtain from the IPO. So same goes to the flowchart. Okay, we obtain this value from the IPO. Okay, so this is how we compare between algorithm and flowchart. So let's say if algorithm enter length, you also put enter length in your flowchart. However, you put it in this symbol. This is the symbol for input. Okay. Also common mistake. Student sometimes forget to use appropriate symbol. You use this symbol instead of parallelogram. You use this symbol, and then you put enter length, which is wrong, So this is a wrong symbol for input. Okay, make sure you are familiar with the correct symbol. So this is for input, and then enter width. Okay, input, enter height. Okay, input. Okay, calculation. Okay, calculation. Equation, either be equation or initialization. There are only two. Okay, initialization or equation. Initialization, like I showed earlier lah. For example, pi equal to 3.142. You want to give value to pi. So you put it in this symbol. Okay, rectangle. And finally, display volume. Okay, display volume, parallelogram, then n. Right? Simple, sequence. Sequential is straightforward. You see the direction is only one way. Okay, you will not see looping over here. You will not see the diamond symbol, which is for decision. Okay, because it is sequential. From top to bottom, single. Okay, single way only. Right, this is another example. Okay, add two numbers. Okay, enter number 1, enter number 2. Okay, this is the symbol. Okay, display sum. Okay, any question?
Sir.
One by one. Apa dia?
Sir, can we put all the input in one parallelogram?
Okay, good question. So let's say if we have two input, can we combine together? The answer is, of course, kan? It is up to you, kan? You are the one who design. Okay, if you want to combine together, put it like this lah. Okay, enter num1, comma, num2. Boleh? No problem. As long as the conditional. Okay, you may put it like this, as long as the input should be in sequence. Meaning that if the system, when you run the system, first user enter num1, and then straight away user need to enter num2, then you may combine. But let's say your program have two input. Okay, for example, num1 and then num2, but the sequence is not in sequence between the input there is another process. Okay, for example, example. Okay, example, example if something like this. This is example. Example, I say example again, kan? This is the case. Okay, enter num1 and then you have calculation. And then you have enter num2. Alhamdulillah. Enter num2. Alamak. Okay, you have enter num2 over here. And then we have calculation. Example okay. Example although you may combine this one no problem, still you can get the value. But let's say this is example. After input num1, you have calculation, and then you have enter num2, and then you have calculation. For example, let's say this is the flow, so you cannot combine lah. Okay, num1, num2, for example. Okay, you cannot combine because in between num1 and num2 there's another process. Example, there's another process that you cannot avoid. So you cannot combine. You understand what I mean, guys? Okay, good. Okay. If no problem to combine, then you can combine. Enter num1, enter num2. Okay, no problem. Okay, another question. Ada question lagi? Tadi macam banyak question. Tak ada dah? No more question? Alright, if no question, then so this is an example of decision. So don't worry, this is just brief. Brief how to write down decision. Decision mainly we use the diamond symbol, and what comes out from the diamond symbol should be two. You cannot have three. For example, sometimes you forget and you put another one over here. No, wrong. This is wrong, for if-else condition. I'm talking about if-else condition. Also, what is if-else? So next week. So it should be only two, true or false. Okay, true or false only. So if it is true, what it will do? If it is false, what it will do? And then it comes back, maybe join together or maybe separate, go separate way. Okay, it's based on the design. All right, this is again decision. Okay, it's up to you. If you want to put it over here or over here or over here, as long as the outcome from the diamond symbol is only two arrow. Okay, this is also acceptable. Okay, so looping. Okay, this is looping. Also use the same symbol. Okay, as you can see, it comes out only two, and true or false, true or false. However, you can see the design, it goes back up and re-enter again the diamond. So this is looping. Okay, this in chapter looping. We are going to discuss this further. Okay, so that's all for sequential logic structure. Okay, over here is some example that you may look at. Okay, but I'm not going to discuss this. Okay, we are going to go straight away for the exercise, for the lab exercise later on. Okay, any question? Any question? So how do you want to check the correctness? The correctness of your flowchart. For the algorithm, you may check it using the dash checking. So for the flowchart, how do you want to check it? Actually, flowchart is much more easier to check. So you just follow the flow from start, and then you make your own notes over here. Okay, so enter length. So what is the value of length? For example, put the notes. Text box. Okay, put a note over here. Okay, enter length. Okay, so length, for example, equal to 10. This is manually check. And then enter width. Okay, width. You enter 10. Height. You enter, okay, 10. And then over here, volume equal to 10. Berapa? 1000. Betul? And then, so display volume, you will get 1000 now. Correct tak? If it is a correct value, then your flowchart is correct. So this is one way to check it manually. This is simple because it is in straight line, sequential logic structure. But if let's say you have the decision. So you need to trace the flow and trace if the decision is false. Okay, so it goes this way. If it is right, goes this way. So trace the value until the end. So what's the value of the end flowchart? That is how you determine whether your flowchart is correct or wrong. Another way to test the flowchart is to use the specific tools specific tools. Okay, for example, Flowgorithm. Okay, this is what we are going to use officially, Flowgorithm. Okay, flowgorithm.org. Alright, so you may download this. Okay, download. Okay, check your system this is for Windows 64-bit. Tahu tak nak check sistem macam mana? Check lah. Check either 64-bit or 32-bit. Download it. Okay, install. Okay, for example, this is mine. Okay, this is very good tools. Saya pun lupa dah macam nak pakai. Function. Ada simbol lah. Okay, alright. Okay, so this is your flowchart. Click over here. Click over here. For example, input. So you check, you click this one. So this click. Okay, input. Okay, and then double click. Double click. Okay, just enter the variable name. For example, over here we have enter length length. Okay, length, length. Okay. And then we have okay, input. Wait. Then we have what tadi?
Height.
Height. Okay. The flow follow the flow and then we have this symbol
Yes.
Simon and the equation is this equation boleh tak copy paste variable alamak tulis pula okay, ini tak boleh copy paste apa tadi volume, okay, volume equal to you need to write down the equation over here, length. So this is the equation. So this one equation is something like this, volume equal to, so this is the equation, we put it over here. And then okay, syntax error. Okay. Terperasan tak? Okay. Volume macam programming pula ada error kan. Okay. And then finally we put output. You see although the color is different but it is the same symbol so these tools differentiate between input and output using color So we want to print volume Okay, volume. Okay, something like that kan. So this is the keyword kan, keyword. For this tools, the keyword for input is input. The keyword for output is output kan. But you can see the different kan. Alright, so once you finish, okay, you may run. It must first be declared. The variable length was not declared. Okay, ada declaration pula kan. So declaration lah. Over here, you need to declare first. I think I show you later on during the lab lah. Okay, how to use these tools properly. Boleh this is just tips for you. So for now, just download and install it first. Maybe you can play around by yourself first. Okay, later on during the lab session, we are going to use this, okay, to solve the question. Boleh So download and install it first. For those yang ada laptop or PC lah tak ada tu, you need to use manually lah. You have to draw manually, okay? Okay, so any question? Okay, question? Habis dah kita? No question If no question, okay, that's all for today. Okay, see you guys on Friday for the lab session. Okay, before that, sekejap ada question ke? Ada question boleh tanya dulu? This is attendant Okay, attendant takkan tak ada kan? Okay, attendant Ada question? Tak ada. Okay, tak ada. See you guys on Friday. Thank you. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you, sir. Waalaikumsalam.
Thank you, sir.
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 Thank you, sir.